All right, so number 5, we are to find the first, second, and the third derivatives of these two functions. The first one of which is y is equal to negative 1 over 2x plus 1 in the denominator, in the quantity. So I think because we have to do this several times, the multiple integral, multiple derivatives. So let's go ahead and write this as negative and then 2x plus 1 to the negative 1. Okay. And then the derivative, of course, is negative times negative 1. That's positive 1. 2x plus 1 to the minus 2. And then remember the chain rule. So you have to multiply this by the derivative of the inside function, which is 2. So I'm going to write that 2 in front. Okay, so negative and negative canceled. So this is positive 2. All right, and then the second derivative is, of course, 2 times negative 2 times 2x plus 1. The new exponent is negative 3. And then you have to remember to multiply this whole thing by the derivative of the inside function, which is 2. So suddenly we have 2, negative 2, and 2. That's negative 8. And then 2x plus 1 to the negative third. The third and the last derivative for this is negative 8 times 3, negative 3. That's 24 times 2x plus 1 raised to the negative fourth power now. And again, multiplying that by the derivative of the inside function. And so the answer is 24 times 2. That's 48 times 2x plus 1 in the quantity and then negative 4. You could also write this as, you don't have to, but maybe it's easier for you to see this as a fraction of 48 divided by this quantity to the fourth power, the quantity being 2x plus 1. Okay, so that is your third derivative. All right, now part B, you have y is equal to negative sine cosine of 2t. Y prime is negative 3, stays the same. And then what's the derivative of cosine? That's negative sine of that thing times the derivative of the inside function. So now we have negative 3 times negative times 2. So that's going to give you a positive 6 sine of 2t, or 2x, right? Okay, the second derivative, 6 stays a 6, and then sine becomes cosine. And then, of course, it's cosine of 2t or 2x times the derivative of 2x. So now you have 12 times cosine of 2x as your second derivative. The third derivative is 12 times, again, the derivative of a cosine function is negative sine. So negative sine of 2x times the derivative of the inside function. And so now this becomes negative 24 times sine of 2x. Okay, and that is your third derivative. Okay, any questions so far? Good. All right, number 6 has 6 problems. All right, part A is very simple. It's the integral of what are we integrating here? It's basically, the understood 1 here, right? It's a constant 1 function you're integrating, but when you do that, you just get x from 1 to 3. Basically, this is 3 minus 1, or the physical interpretation of this integral is that it is the length of the interval from 1 to 3. Of course, that's 2, okay? That's all it says. And by the way, in general, if you just integrate from A to B, just the function 1, this will just be b minus a, which is the length of this interval. And you will learn in calculus 3 that there's a 2-dimensional version of it, which is the area of the region R, and so on. Okay, so this next one, part B, is not trivial because it's x to the negative fourth power. What happens when you integrate x to the a certain power? Well, you add 1 to it, but remember, you have to be a little careful when you add 1 to a negative number. That's going to give you negative 3, and that will be your new denominator. So this is basically your antiderivative, right? And so this is what you will get. It's negative 1/3 times x to the negative third power. And so anytime you do this, you should mentally differentiate this. The negative 3 and negative 3 cancel, and the new exponent after you differentiate this will be negative 4, which is exactly what you want. So this is your correct answer, right? Correct antiderivative. I personally like to take these numbers out when you integrate these things. So let's take out negative 1/3, and the rest is 1 over 27. That's 1 over 3 to the third power minus 1 over x1 to the third power, which is 1, right? So this is negative 1/3 times what do you have here? It's 27 over 27. You can write this as 27 over 27 if you like. And so what is that? Well, that's a negative 26 over 27. And so that would be 26 over 81, and that should be a positive number, right? Okay, let's go to part C. X to negative 1. If you add 1 to negative 1, you get 0. Okay, so this is a very special case, right? Remember, basically what you have is this thing that looks like that logarithmic expression. The answer to this is the natural log of the absolute value of x as x goes from 1 to 3. So this is log of 3. When mathematicians say the log of 3, that's the natural log, because that's the only natural thing we mean by the log, the log. And then, of course, it's minus natural log of 1, all right? Everybody should know at this point, it's 0. Natural log of 1 is 0. So the answer is the natural log of 3. You should leave this answer, okay? Don't try to make this into a decimal equivalent, first of all, because you don't have a calculator, and no matter how many digits you write, you will not get the exact answer. The only way to express the exact answer to this question is basically to write the ln of 3, okay? Okay, let's go to D. This is also, okay, so let's see. The first 3 were definite integrals. This is going to be an indefinite integral. All right, so this is complicated, right? What do you do when you have x times sine of this thing here? Well, fortunately, you can let u be 3x2, and then du will be 6x dx. Of course, I don't have a 6x dx, but I can make 6x dx inside as long as you divide everything by 6 on the outside. So this will be 1/6 times the integral of sine of u, that's sine of 3x squared, and then everything else left here, 6x dx, is just going to be du. So in this one step, we have made a problem much simpler, right? So what's the antiderivative of sine of u? That's going to be the negative cosine of u, right? So I'm going to put a negative sign here, and then cosine of u plus c. Don't forget that u plus c. So the answer is negative 1/6 cosine of 3x squared plus c. Make sure you have this plus c, and make sure you have the negative sign out here, because that is your answer, right? All right, so that you have to make sure of these details. All right, part E has e to the negative 4x. All right, so again, I'm going to let u be negative 4x. And then here, let me just go ahead and move this. It's too close to each other. All right, so oops, du is negative 4 dx, which I don't have yet. Okay, but I can go ahead and just assume that there's a negative 4 here. As long as I divide by negative 4 on the outside, I am okay. Negative 1/4. It's so nice that we can do this kind of manipulation when you do mathematics, right? E to the u is my new integrand, okay? Because e to the negative 4x is now called e to the u. And then negative 4 dx is my du. So again, in one simple step, I have simplified this integral much greatly. All right, so the answer is negative 1/4. And of course, the antiderivative of e to the u is the easiest one. It's e to the u, and then of course, plus c. And that's negative 1/4 e to the negative 4x plus c. If in doubt, try to differentiate this. You'll see that negative 1/4 and negative 4 will cancel each other. And you will end up with e to the negative for x as we anticipate. All right, that's the answer, by the way, right? Make sure you have the plus c. Okay, the next one also looks fairly complicated, but if you let u be the denominator, by the way, how do you know this is what the u should be? Well, because you have x on the top, and you know by letting u be this square, function x square, you will end up with the first degree x term here, right? That's 2x dx. And I can easily create this too. That's how I know. Now, if this didn't work, then you want to try something else, okay? And you can do several attempts until you find out something that would work. All right, so in this case, I have 2x dx. And by the way, this is a definite integral, which does make a little difference, as I will show you in a minute. I don't have a 2, but I can easily create a 2 inside, as long as you divide the outside by 2 also. So this becomes 1/2 integral. And here is an important point. I'm not going to write down 0 and 2 because I am about to shift everything in terms of u. And these numbers here, 0 and 2, these are the x numbers. They are not necessarily the same in u. In fact, let's go ahead and calculate this. When x goes, all right, so x goes from 0 to 2, right? When x is 0, this equation tells me u is 0 squared plus 1. Right? Of course. And so u is 1 at the beginning of this interval. And when x is equal to 2, this equation tells you u is 2 squared plus 1. That's 5. So in the new integral, in the world of u, without using any x, okay, it's going to be 1/2 times the integral from 1 to 5 of, the top is 2x dx, which is du. The bottom is x squared plus 1, which is u. Okay. Now, once you make this shift in a definite integral from the x world to the u world, make sure you don't use any x anymore. Okay. Nowhere in this expression should you see the letter u or value letter x or the values of x. This 1 and 5 are the u values, not the x values. Okay, so this will be the natural log of u, absolute value of u, as u goes from 1 to 5. So this is natural log of 5 minus the natural log of 1. And of course, that's just 0. So the answer is 1/2 times the natural log of 5. Of course, that is the same thing if you want to write this in different ways. It's the same as the natural log of 5 to the 1/2, which is the natural log of the square root of 5. Any of these answers will be accepted for part F. Okay, number 7, we are simply to write something about their end behaviors. A is x to the 4th plus 2x plus 1, and B is a 5th degree polynomial. You probably learned these things in either college algebra or pre-calculus class. Basically, all this depends on the first leading coefficient, whether it's positive or negative, and the power. Okay, what is the highest degree power of these polynomials? X to the 4th. Well, if it's an even function, negative 1,000,000 to the 4th power is a positive number, right? So whatever happens close to the origin here, eventually the graph will go to the positive infinity and positive infinity, regardless of whether x is approaching negative infinity or positive infinity. So as x goes to negative infinity, the function will go to positive infinity. And as x goes to positive infinity, of course, this whole expression goes to the positive infinity. So why do we not have to worry about this last part here? Well, because when x is very large or very small, like approaching negative infinity, these things actually don't make a lot of difference, okay? It's going to be dominated by the largest number coefficient, the largest number, the highest order or highest degree term. And so that's the only thing you have to worry about. For this one here, part B, again, something happens around the origin, around small x values. You may have ups and downs here, but eventually, as x approaches positive infinity, this thing will approach the positive infinity, and therefore y goes to the positive infinity. But the difference here is as x approaches negative infinity, this will approach negative infinity. So that's going to be this way. And that's all we mean by the end behavior of each function. So that's what, you just have to write. All right, so that's number 7. All right, I think we'll go into a new segment of this video starting number 8.